All right. Okay. So this is today's schedule. We're going to first go over what is MATLAB, how to install it using your UCLA email, as well as just navigating the environment itself. Then we'll move on to some basic MATLAB commands, such as executing them, displaying variables, and doing other mathematical functions using those commands. Then we'll move on to something a little bit more complicated, combining those commands to create a script, and then looking into vectors slash matrices, such as arrays, and using some built-in functions that will help us with just like plotting different things, as well as looking at into indexing into arrays, extracting its elements. Then we'll move on to plotting data, creating really nice graphs with our arrays. And then we'll move on to adding more logic to our scripts using like if, else if statements and for loops. Then once that's all done, we'll have our famous Kahoot at the end for an Amazon gift card. And then we have a small project that you will be able to do on your own, and then we'll go over it together at the end. Then if you stay for all of that, we'll release our SMD soldering application link, where you'll be able to RSVP to our soldering workshop in week 7. And then finally at the end, there's just like a quick presentation about DigiKey and a giveaway for that. And then moving on. So what is MATLAB? It stands for Matrix Laboratory, and it's primarily used in industry or even in school to manipulate, obviously, matrices in its name. And we'll see why that is in a second. It's also a mathematical environment and a programming language, which is very similar to Python. So if you know a little bit of Python, transferring those skills over will be pretty easy. But if you also don't know Python or MATLAB, that's like totally fine. We're gonna go over all of the syntax in a little bit. Also, MATLAB has an advantage over like the other programming languages because it's specifically made to mathematically compute some pretty complicated things. Has a lot of built-in software as well for numerical computation, data visualization as well. And so it's guaranteed that you will have to use MATLAB for a project or homework in the following courses listed over here. There isn't a course specifically for MATLAB that you will have to take like as an E major, CE major, CSC, or a CS major. So hopefully this workshop will complement the material that you will need for those classes. And as you can see, MATLAB, it spans a wide range of fields. So like signal image processing, control systems, wireless communications, robotics, stats, deep learning, etc. And so our first step is installing MATLAB. Once again, it's free for UCLA students. It originally cost like 150 bucks. So, you know, swoop in, get this free software as a Bruin. If you don't have space on your computer, or you might have to free up some because it's like a few gigabytes, but click on this link over here and then you'll be redirected to some instructions on how to install MATLAB using your UCLA email. And we're going to wait just like, I guess, a few minutes for people who haven't installed it yet so that they can get going.
And let us know if you've come in late and don't have a link to the slides or to the check-in. We can send that back out.
Yeah. Also, thank you to those who turn on their camera. Your faces are very beautiful.
Also, I'd like to bring up another usage of MATLAB is often in research. So that's a big part of it. Actually, the research I'm doing right now involves a whole system that was made to operate in MATLAB. So it's a good skill to know for that.
Also very good to put on your resume.
Yes.
Another skill. Boop, 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 boop. Okay. I guess in the chat, if you, I need to open this up real quick. If you haven't installed it yet, can you just like say something in the chat so we don't just like go off onto the next slide? All right, nice, Preston. All right, we'll do a little waiting. Sorry, MATLAB's the big boy to install.
What product? It says like select products. Should we select all, or should we just do the ones that they recommend?
Just do the recommended one. If possible, you can just select is there one where it just says MATLAB?
It's MATLAB, and then there's like Simulink, 5G Toolbox, and there's like a giant list of them.
Okay, just MATLAB and Simulink, because most of the
There's
time
like,
you don't need to install the others.
all right.
Yeah, for most of the stuff for the stuff we're doing, definitely, and for most of the more basic stuff, that simple thing should be fine. Then you might have to go in later and download a couple extra things if certain functions don't work, but that's fine.
I'll just put in the chat. Yes, exactly what Andrew said. If you install the rest of the others, you'll be here forever.
So I think one more person joined, so I'm going to resend the link to the slides and the check-in.
Okay, thank you for that.
I apologize to the people who have seen that same link probably 20 times now.
It's all good. You're doing God's work, Travis. And then also, if you have it installed already, you can just open it up right now so you can follow along a little bit better.
Yes, and for those of you who are in progress, let us know when you're done. We'll wait a couple more minutes.
Mm-hmm. Also, the slides look hefty, but it won't take that long. Some of them are really quick, so it is all good.
All right, great. So yeah, we'll give it another minute then, and then we'll start. And don't panic if you're still installing. The first couple steps are pretty self-explanatory.
6:14. We'll start again.
All right.
How many of y'all did idea hacks this past weekend? We got Andrew.
Preston. Get a thumbs up from David. Dominic. Nice.
We got a lot of support for Preston. All right, I think we're gonna move on to the next slide. It's just navigating the ID, so there'll be some time left for it to still install. All right, so now we're going to move on to navigating the MATLAB IDE. When you open it up, you're gonna see like 3 different windows. The first is just the current folder you're in, and essentially This is useful if you want to import data using like a CSV file or import an image and so on. And then you have your command window where you'll execute all of your commands here and then see the output of that. And then you have your workspace right here. So that's where you'll see all your variables that have been saved after executing previous commands. And it's just really easy for you, a really organized way for you to keep track of everything. All right, now we're getting into some of the MATLAB commands. To execute a command, you see these like 2 greater than signs right here. It's just the MATLAB prompt. That's just indicating that you type in your command right there and you press enter to execute it. And if you have MATLAB open right now, you can just do a little quick like test with it. Just type in 3 times 5 in the command window. And then your second task, you can try to save that as a variable. So some of the syntax for naming a variable in MATLAB, all of them have to start with a letter. And then for the rest of the characters, you can only contain letters, numbers, or underscores. And to set a variable, you use the equal operator, which assigns the whatever evaluated expression on the right to the variable on the left. So after you type in res equals 3 times 5 in your command line, you should see the output as 15 that will appear. And here are a couple ways where you can manipulate your variable. For those who haven't seen like just like programming like addition, if you want to add onto your old variable, you have to put the same variable, or it's like res equals res plus 1. And essentially what this is doing is taking your old value of result, adding 1 to it, and setting it back to that result. So what this should give you is 15 plus 1, which is 16. So now res has a value of 16. And then if you enter a command without the semicolon, that's going to display a result. But if you put a semicolon at the end, it's just going to execute your command without having like a long list of your output. So let me know if in the chat if you like tried these tasks out, just with like a yes or a no if you're still installing.
We have yeses.
Thank you.
Oh no, and some installing. Hopefully it's close for you guys.
Okay. This one is like pretty basic, like just like calculations you could put on like the calculator, except the variables. But we're gonna move on because there's like a lot we have to get through. So if you want to recall a previous command, you don't want to type it all over again, especially if it's really long. So you want to press the up arrow key. And as you can see, here's a history of what I've typed in. And then if you want to display the current variable value for like debugging purposes or anything, you can just type in your variable name, press enter, or you can also look at your workspace and then see the value for that there without having to type in your command window. And there are a few built-in functions and constants that will be useful. So obviously there's pi. It's pretty common and they should probably have a constant for that, which they do. And some other functions that you have include your trig function, so like sin, cosine, or sine, cosine, tangent, and a bunch of other ones. Also, MATLAB uses parentheses to pass inputs to functions, very similar to your standard mathematical notation. As you can see right here, you can calculate or evaluate cosine of pi, and that should give you -1. And you can also handle imaginary numbers as well. So if you do like the square root of like -9, it'll give you 3i. And for organizational purposes, you can clear your command window by typing in CLC and pressing enter. Or if you want to clear all of your workspace's variables, you type in the actual word clear. It's a little bit like non-intuitive, but you know, it is what it is. So CLC and clear.
Yes, question? Do you hear somebody?
Yeah, anyone
no? All right, so one of the big things that we actually want to do with MATLAB is create something called scripts. And you might be wondering what those are, and what it basically is just reusable sections of your MATLAB code. And you might ask, why is that any different than what we do in like C or C++ or something like that? But the difference is that MATLAB, as you can tell, is sort of a command line oriented language. You type in a single line, hit enter, and then it executes your command. And this is something that you'll also see if you've ever used the Linux terminal on a Mac or PuTTY on Windows. It's the same sort of idea. Sometimes you want to be able to have a file that executes multiple commands at a time, and that's where scripts come in. So how we're going to get started creating scripts is using the new live script button, which hopefully you see up at the top left of your MATLAB window. And so you're just going to click on that, and you'll notice that the window will change a little bit. A new command window will appear in the middle. And that shows in the next slide. So it'll appear in the middle like this, and that's where you're going to do your coding. And once we actually end up running it, it'll show up on the right. So you can see that what we've done on the left is just executed a couple of simple instructions where we give values to particular variables. So you can see up here, we've given A the value 5 and B the value 2, and then C the value A over B. So when you click that run symbol, which is up at the top right, what it will do is show output in the output pane that's basically equivalent to if you just in the command window typed each one of those commands individually. Like you can see that it'll type out A equals 5, like it would if that's what you entered, then B equals 2. But then in the third instance, instead of writing out A over B, it'll actually write out the value that's requested in the output pane. So hopefully all of that makes sense to you. And if anytime any of what I'm saying doesn't make sense, as always, feel free to speak up or type questions in the chat. So there's also some extra features that we can do in the scripting mode of MATLAB. And one of those is adding text descriptions. So this is especially useful if you're going to be passing some of your scripts off to other people, or if you're just a future version of yourself is looking back at your code and has no idea what you were thinking. And so what you can do is annotate it. It's basically like comments in any other kind of language. So you can click the text icon up at the top next to the live editor up there. Hopefully you can see that. And then it'll sort of switch the mode that you're in. So it will allow you to write any text that you wish to between chunks of your MATLAB code. And it's super easy to switch back and forth. All you have to do is click the code icon that's just a little bit to the right of that, and you can switch right back. So that's sort of a kind of section break. But if you actually want to make real section breaks that you can run individually, you can use the section break button that's up there. Hopefully that's pretty visible for you. And so what this does that's important is it allows you to run individual sections of your code without running the rest of your program. So if you have a certain bit that you're not exactly sure is correct, then you can always click the run section button and make a section break and see what happens. So like in this particular instance, we have our dividing two numbers set up that we had before. But if we want to have a multiplying number part, then we can just check that out separately. So if we like ran the whole thing and then wanted to test out multiplying two numbers again, we could click on it and then simply click run section, and it'll do that without re-executing all the other commands that you've made. So the next big part of MATLAB that we want to talk about are vectors and matrices. And there's a few functions that we're going to get into as well, including the linspace, rand, ones and zeros functions. And we'll get into what all that means in just a second. So first of all, one sort of counterintuitive thing to remember is that in MATLAB, every variable is actually an array. And that goes for even just simple single letters, or single numbers like you've been using before. So for instance, in the a equals 5 that we did in the last set of slides, the 5 is actually in a 1-by-1 array. And so that just expands onwards to where you can make each variable have a certain amount of numbers in an array that is actually its value. So you're probably familiar with arrays from whatever coding you've done before in Python or C++, but a really annoying thing to remember about arrays in MATLAB is that they're indexed starting from 1. So that'll mess your computer science brain up a little bit, but the first element is not index 0. And this is also the way it is if you've taken a linear algebra course at UCLA, such as 33A, you'll notice the same kind of thing happening. So like in Python and C++, we use bracket notation to create our arrays. And now how we do this is that each row element will be separated by a space when you're declaring it. So if we take a look real quick down at the matrix, we have B equals 2 space 3, which means we have a 2 and a 3 on the same row. And you can see that in our graphical representation up here too. And then next to that, we have 6 and -9 separated by a space. And that means that 6 and -9 on the same row. Now, how we switch columns is by that semicolon that you may have noticed right there. So you can see that in our matrix, that's how we know when 2, 3, and 6, 9 go to different columns. And so this carries on even further. You can see if we want to have just a single column vector that's just vertical, we can have a semicolon between each element in that column vector. And if we want to have a row vector that's just all horizontal, we just use spaces in between it. So hopefully that all makes sense. And you can make vectors of really any dimensions using this format. All right, so we've got a couple things for you to try out now. Hopefully everybody's gotten MATLAB downloaded by now. If you don't, put it in the chat just so we can continue feeling sorry for you. I do feel bad about that. But if you do, then follow along. So first, 87% for Dominic, nice. Rest down with 50%. All right, you'll get there. By the time our project comes along at the end, it will be downloaded, I promise. So first of all, what we want you to do is just create a scalar variable named a and set it equal to 4. So that's pretty much similar to what we've been doing before. A scalar variable, as you saw in the last slide, is just simply an array of array of size 1, 1. So how you do that, of course, is just say a equals 4. Now, if you create a row vector and name it b with 2 elements, 7 and 9, what are you going to want to have between 7 and 9? Is that going to be a space or a semicolon? Just type it in the chat. Exactly, yeah. Just all you have to do is remember that if you're doing a row, you just need spaces. And I think that's pretty simple because when you're writing it out, that's what you did. So similarly, if you're making a column vector with elements with 2 elements, 7 and 9, you're going to go through a similar process, but instead of spaces, you're just going to want to have semicolons. So you can type that out into your MATLAB, hit enter, and see how it formats it for you, just to prove that we're right. So the next task is sort of putting that all together. You want to create a matrix with the following values in the following order. So, could somebody put in the chat how they would approach this or what the format would be for making this? This isn't the Amazon gift card question, but think of it as a warm-up. That's actually not correct, but it's a good try. Yes, great job, Kat. So we can see that we've got 2 rows right here. The first row has elements 5, 6, and 7. And of course, we're going to need spaces between those because it's a row. And then the second column is indicated by a semicolon right here, and the elements in there are just separated by spaces as well. So hopefully that all makes sense for you guys. So what if we have a whole bunch of elements that we want to add in an array, but our fingers are tired of typing, so we don't want to have to put every single one in there manually? Well, we can do this with a couple of notations that we're going to go over. The first one of these is just using a colon notation. And so how we do this is instead of actually manually inputting each element, we sort of specify a range, and then we specify a spacing between the top and bottom elements of the range to get the elements that we want. Now, one important thing to note about this is that both start range and end range are inclusive, which means they will be featured in the matrix that you eventually print out. So the first item will be, if you look in the example, it'll be the element we want to start with, which in our case is 20. So that will be our first element. Then we look at the last one, which is 26. And we want all the elements between there that have a spacing of 2. So you can see what that looks like right here. We have 20, then 2 more than that's 22, 2 more than that's 24, and 2 more than that is 26. So we've got an evenly spaced matrix right here, or evenly spaced vector, I should say here. And that's really useful, like if we had between 2 and 100 evenly spaced 2, you can see how that would be very difficult to type out by yourself. So it's really convenient to use this colon notation. So hopefully that all makes sense. If it doesn't, as always, feel free to interrupt. But we have a second way we can, that's a good idea. It's not actually divisible by the spacing. It's actually a good, so you could actually try that out. So if you have MATLAB open, try doing like the previous problem, but say make it 27 as the index, as a top element.
It should just exclude like the last.
Yeah, I would think so. So in that case, I guess it wouldn't be inclusive for the final element, but in most cases, the bottom and top elements are included. All right, so the second way that we can do something like this is with the linspace function. So if you know the number of elements that you want to be in the vector that you're creating, but don't exactly know the spacing, then you use linspace. So how this works is actually somewhat similar to how colon notation works. You're going to need a first and a last element. And once again, this will be inclusive. Both those elements will be featured in your vector. But this time, the third element will be the number of elements that you want to include between the top and bottom number. And it will do an evenly spaced split up of that. So for example, say we use x equals linspace 0, 1, 5. So our first element is going to be 0. Our last element is going to be 1. And we want 5 elements in our vector. So we'll choose evenly spaced elements to get us to what we need. We can see we have 5 elements right here, and there's an even spacing of 0.25 in between them. And this is convenient because we didn't have to calculate what that even spacing would be. It automatically did it for us. All right, guys, so here is our first question, our Amazon gift card question. If you want to create an evenly spaced vector from 1 to 2 pi with 100 elements, would you use linspace or colon? Explain why. So remember that you are going to have to explain why in your answer or you will not get credit for it. But let's go. First person in there gets it. Ooh, Cameron was on the trigger. Let's see, linspace, because you don't know spacing. Yes, I think I agree with Cameron's answer right here. So don't know if we have, just put your email in a private message to Jackie, I guess. I think we already have it, but just in case, so we remember.
Your email. All right, moving on. Okay, good job, David, on downloading. So we also have the rand function. An input is n, and it returns an n by n matrix of random numbers between 0 and 1. However, if you want to change the dimension of your matrix of random numbers, you can specify n and m. And then here's like a little quick example of how you can use it. So if you just have one input to your rand function, it's going to create a square matrix of whatever number you input here. So rand2 creates a 2 by 2 square matrix of random numbers between 0 and 1. And rand2, 3 will create a 2 by 3 matrix of random numbers. I guess this function is pretty useful sometimes in stats where you have to like plot distributions and so on. There's also the ones and zeros function. The ones function creates a matrix of all ones, and the zeros function creates a matrix of all zeros. People typically use this to kind of initialize a matrix or even create like step functions using the ones function. And here's a quick example. The syntax is very similar to the rand function in regards to its inputs. So if you have one input to your ones function, you're going to create a square matrix, and this is going to create a 2 by 2 square matrix of ones. And if you have 2 inputs, you're going to create a 6 by 3 matrix. Since we're using the zeros function, we're going to create a 6 by 3 matrix of zeros, as you can see over here. And so now we're just going to look at how we're going to index into an array after creating them. So just for like purposes to know what like indexing an array is, it's when you refer to an element inside the array and you want to extract that value. And like Travis said, indices start at 1, not 0, which is very different from all your other programming languages, and is why people make fun of MATLAB and they say it's not actual programming language. But if you want to extract an element at a specific index, you just type in your array name, variable name, and then use parentheses rather than brackets of your specified or specific index. And then if you want a range or a subset of your array, you can specify your start index, end index. For matrices, you want to specify your matrix name and then your specific row index and then column index. If you use a colon on its own, it actually, in replacement of these two parameters, it actually refers to the entire row or column. And we'll see in the example on how we can use that to access certain elements. And if you don't know how big your matrix or your array is, you can use the n keyword to refer to your last index. So let's look at a quick example. So x of 2 indexes into position 2. So as you can see over here, x of 2 should return our second element. And then x of 1, 3 will index into row 1, column 3. And then we have x of 1, colon. And what this means is we're going to look at row 1 and the entire column, or all of the columns. So like, I don't think I have it over here. Oh, sorry, right here. So we have row 1 and we're taking all of the columns. So it's just specifying the entire row 1. And then we're using the keyword end. So x of end, that means your last row, comma 1. So that's your first column, your last row and your first column. So bottom left of your matrix. And then now if you want to actually assign a certain index to a different element, you just use the assignment operator, which is just an equal sign. So this is changing the array A at position 3 and setting it equal to 5. Something else that would be pretty useful when looking at arrays is looking at the max and min values. So you have these two built-in functions, max and min, and you just input your array name into it. And what this will do is just return your max or min value. If you want the index of your max or min value, actually, you can use this kind of syntax where you have two brackets and then specify two variables of your choice, but the first one is always going to be your max or min value, and then your second element will always be the index of that. And so sometimes you want to know the size of your array as well. So you can just use the built-in size function. And then again, if you want to know the dimensionality of your matrix, you can use the bracket notation with two elements again. So the first would be the number of rows. The second element would be the number of columns. And then this should return right here, your number of rows and number of columns. And then I'll pass it on to Travis now.
Sure. So we've seen a lot of what we can do with just plain numbers in MATLAB, but one of the really cool features it has is the ability to actually plot data for us. As we say, the aesthetic side of MATLAB. All right, so how to do this? One of the easiest ways is just by plotting two vectors of the same length against each other. And what do I mean by this? I mean, say we have a vector x equals to, say, 4 elements, and then another vector y equals to another 4 elements. What we can do is say plot x and y. And what it will do is sort of create a Cartesian plane for us where the first element, x, is plotted on the x-axis as opposed to y on the y-axis. So it plots two vectors together against each other. And then we get a plot like we can see on the right. So there's a lot of options that we can implement when dealing with our plots. And we can see that in right above the example right here. There's a formatting string that we give to it that has 3 parameters to it. The first one is the color. The second one is the style of the line. And that can be something like dotted or just solid or dashed. And then finally a marker style, which is where what the actual points look like. Like I believe they have a square, a triangle, circle, and other things like that. So we can see an example of what that looks like right below. We have our x and y vectors plotted against each other. And then our string is r-o. So as we can see, the R means red, that makes sense. The solid line is equivalent to a dash, and the circle is an O. And so as you can imagine, you can just change up that string with appropriate values to make your plotted line look different. And there's a lot of info on how to do that on MathWorks, and you can see a link on that past slide right there. Exactly.
Sorry, I accidentally clicked on the link. How do I do full screen? Okay. Can everyone see? Okay.
Perfect. So you might be tempted, if you want to actually plot multiple things on the same graph, to just do 2 plot statements in a row. 1 second. Actually, we're getting onto that in 1 second. All right. So one thing that we can do with plotting is plot a single vector. Like last time, we plotted 2 vectors against each other. But what we can actually do is plot a single one. And in that case, MATLAB makes up its own x for us. And how that will work is, for instance, we have a v1 vector up there. And so it'll just assign a corresponding 1 to the first element, 2 to the second element, and so on. You can see what that looks like below. So it'll just basically say, since the first element is 4.0753, we'll match up 1 and 4.0753, and so on. Hopefully that makes sense. And as before, we also have some additional options that we want to do. And here's one that we didn't talk about last time, which is the line width property. And so all we need to do there is give the appropriate line width keyword, followed by a comma and then a number. And as you can imagine, larger numbers will be equivalent with a thicker line, whereas smaller numbers will be a thinner line. And so as before, we gave you some extra links. And Jackie, I think we might have missed a slide. Can you go back one? Yes, there we go. Yes. So if we want to plot multiple graphs on the same graph, you might be tempted to think we could just do that by giving 2 plot statements in a row, but we actually cannot do that. So what we'll need to do first is turn the hold on property on by giving the keywords hold on, surprisingly enough. And so what that does is it tells MATLAB that you want to keep on marking things on the same graph. And you can just repeatedly do this. I've done plot x1, y1 right here, followed by a hold on, then x2, y2, and I can just keep on going with as many plot statements as I like, and they will all show up on the same graph. Now, if I want to turn this behavior off, as you might expect, you can just say hold off in the command window, and then it will start creating new plots for you every time again. All right, so it's all great that we've learned how to actually make plots, but if you were to give either of the plots on the last page to somebody else, they would have absolutely no idea what to do with it because it doesn't have any descriptors or any labels or anything. Fortunately, MATLAB gives us a lot of ways to do this. So there are keyword functions right here, and they're all pretty self-explanatory, but I'll go through them. So as you might expect, the title function will allow you to put a title in bold at the top of your page. And so that simply works. You give the title keyword parentheses and then put a string in quotation marks in the spot for arguments. And then it's just a similar thing with X label and Y label. If you type in X label in a string, it'll put a small label under that axis for you so that you know exactly what you're dealing with. And lastly, an important one, if you're dealing with more than one plot on a single graph, is the legend idea. And so the legend, as you can see in the top right, it will distinguish between the 2 different plots on there. So let's look through our example real quick. I've plotted an x1, y1 vectors. I put my hold on because I want to put more than one on the same page. Then I plot the second one. I give a title on the top, sample mass, as you can see, and I label the y so we know what we're dealing with. And then the all-important legend, because otherwise we wouldn't be able to know whether blue was our x1, y1, or whether blue was our x2, y2. But since we give our legend right here, we can easily distinguish between the two. And I guess another thing worth noting here is that although we didn't specify colors for them, MATLAB will automatically choose different colors for the two plots, so you can distinguish them. All right, so you guys are probably pretty familiar with conditional statements from whatever other languages you've done, like C++ or Python. And they're actually very similar in MATLAB, but with just a couple differences, and that's what we're going to get into today. So if statements, as usual, they have an if, else if, else structure. Unlike in some other languages like C++, else if is not two words, it's a single word. So that's one thing to bear in mind. As you might expect, the if-else statements work on conditionals that are true or not true and execute certain statements based on that. Now, one thing to note is that we do not require parentheses around it. As you can see in the upper right in the example, you might expect that we would need parentheses to contain and let MATLAB know which our conditional statement is, but MATLAB is very good with white space and it will actually recognize that for us. We also don't need any brackets. It will recognize that for us as well. But one thing you do have to remember to do is after the entire conditional statement, you must put the keyword end so that the compiler knows that you are finished. So let's see some examples of that. So if we look on the left, we can see our good old Boolean operators equals right here. So if the name string we pass in is equal to Sarah, then we will assign the variable x to 1. And we have our else if conditional below it and our else, and then our all important end at the end of our statement. So the compiler knows that we are done. And we've got a similar thing going on the right. We can use our good old less than, greater than, and so on as well. But one important thing to note here is that even for longer, more complicated statements like on the else if, we still don't need parentheses. You can see we've got two conditionals and logical and right there. And we just have to keep track of it, but MATLAB is doing fine with that. The disp function, that's a good question. That will just simply print things out to the display. All right, so now that we've done our if statements, let's go on to for loops. And once again, the big difference right here is that, well, there are a couple differences if you're used to C++. Let me get into that first. So if you've done Python before, then you're probably familiar with this kind of for loop that just has a start index and colon and end index. So, but let me explain how that works if you haven't. So instead of having multiple statements, what we basically do here is assign a variable, in our case counter, to a particular start. And then each time we go through the loop, this for loop will automatically increment it for us. So we don't have to worry about doing that ourselves. And as we mentioned here, it's usually the way we do it is to start the counter at 1, since that's kind of a thing in MATLAB, although you might usually do 0 in other languages. So we can look at a quick example of how that works. If we have a particular vector that has the elements 3, 6, and 9 in it, then we can have a for loop where we start our index at 1, and index is a variable, remember that. We start our index at 1, and then until we reach the length of our vector, that's also a function I'm not sure if we mentioned before, we can say length v, and it will count that as the number of elements in our v matrix. And for each element in there, we will print to the display the element at that index. So when we index into arrays, I think we mentioned this before, but when we index into arrays in MATLAB, we actually use parentheses and not regular straight brackets. So that's a bit of a weird thing about MATLAB too, just something to remember. And then of course, we must have the all important end statement at the end, just to let everybody know that we're done with our for loop. All right, so we've seen how we can plot actual data, but you might be wondering if there's an extra function we can do with this that's sort of just plotting more generic functions where we don't actually have the data yet. And as a matter of fact, there is. And that's the fplot function. So instead of actually having a couple vectors that you want to plot, you can sort of plot a generic function that you create. And we do this with the @ keyword. So you can see how this works for the example of my function. So we need first things, the @ keyword, and that lets us know that we're dealing with a function. Immediately following that is the list of arguments that we wish to have in our function. In our case, it's just a single one, because this is a function in x. And so all we need to include is x. And then right after that, we have the actual body of the function. So basically you can read that as, here we have a function in x, and that function is x squared. So hopefully that all makes sense. And now if you actually want to plot that, you use the fplot function, as you can see on the left. You give it the name of your function first as a first parameter, and then secondly, the interval over which you wish to plot it. So in our particular example, we're feeding it the function that we've created, myfunc, and then we're going an interval from -5 to 5. And you can see how that looks on the plot over here. So that's just a useful thing if we want to visualize functions. Alrighty, so next we have a all-important Kahoot. This will be your chance to win an Amazon gift card as well. So you can get that started.
Did you want to launch it, or do you want me to launch it?
I can do it. Let me see. I think I can screen share.
I'm going to stop the share.
All right.
How is
share?
Does everyone have MATLAB installed? Oh, nice, Preston. Yay. Okay.
I'm going to full screen that. All right, can everybody see the pen?
Yes, we can see the pen.
All right. I should always phrase those as can anybody not see the pen? That's the better way to do it.
I think we're on team mode. Is it supposed to be on team mode?
Oh.
Is it? Oh, 1 second. Let me hop back then. I think it might not be. All right, sorry about that. Let's go back to intro to MATLAB here. Let's go classic mode, my bad.
Thank you for the catch.
Yes, I appreciate that. All right, now we have the pen again.
For anyone who's new, this is for an Amazon gift card worth $5. So if you get first place, you'll get it. Yeah, so after we do the Kahoot, please stay for like a little bit to do like the project. It's pretty short, I would say, but you'll be able to apply your knowledge from today's workshop, and it'll be good knowledge.
Yes, it will. All right, so I think we have 19 people so far, so we probably have a few more to join up. If you guys are having any trouble joining, please just let us know. I'll wait another minute. Let me rephrase. If anybody still wants to join but hasn't joined, just let me know in the chat. Otherwise, I'll start it in 30 seconds. There we go. 21. All right, starting in 10. Alrighty, let's get started.
All right. Do you have the audio, Travis? That's what makes it.
All right, first question, what does MATLAB stand for? Option, mathematical laboratory, matrix laboratory, meth laboratory, or mattress laboratory.
Wow, no one picked a math laboratory.
You guys are too smart for that. Next. All right. So nice job to Roy. You're on top for now. Let's see if anybody can topple Roy. So where can you see all of the current variables on your screen? In the workspace, command window, current directory, or search bar? Very nice. Yes, it is workspace. Ooh, we got Roy still on top, but only by 1 point. Very nice. All right, next question. Where do you execute commands in MATLAB? Workspace, command window, current directory, or search bar?
I think I accidentally put multiple, but I think it's just one.
Yeah.
I'm sorry.
Very nice.
It's okay, they got it right.
Yes, I think it
It's
is
a
technically just command window, but all right, we're continuing. Roy has still maintained his top spot. Very nice. Let's see. Next, we have, what does including the semicolon after a command do? Does it run the command and display the result? Does it not run the command and not display the result? Does it not run the command and displays the result? Or does it run the command and not display the result? So many semantics. Very nice. Yeah, a semicolon is basically telling it, yeah, you don't have to print out what we just said. We know what we're talking about. Ooh, Roy has been toppled. Very nice, Margot. So what is the command to clear your workspace? Is it clear or CLC?
This was
Ooh,
the
yeah.
tricky one. I'm so sorry.
Mm.
But yeah, CLC clears your command line like output, but not your workspace.
Next. So we have Margot still on top. Nice job. All right, every MATLAB variable is a/an. Is it an array, an int, a float, a string? Very nice. Yes, every MATLAB variable is an array, even if it's just of size 1. Margot still on top. Very nice. What does the function call x equals 1s 2 do? Yes, nice job. So we have Margot still on top, but Corwin's making a climb. Let's see how it goes next. How would you access the third element of an array called x? Yes, this was a bit of a tricky one because you're all used to C and Python, but MATLAB is just trying to be mean. How do you plot multiple graphs on the same XY axis? Very nice. Yes, you got to get MATLAB to hold on to that information for you and not just throw it away. And we still have Margot on the top. Let's see if she can maintain the lead. Only 3 questions left. What are the 3 conditional statements? This is a trick question because it's very different for very different languages. But yes, it is else if, all one word in the middle. And Margot has maintained the lead. Second to last question. How would you create a for loop that loops through the first 3 elements of an array? Good job, guys. Yeah, I think you've all internalized the fact that MATLAB starts at 1. So this is good. All right, last question. This decides our gift card winner. How do you recall a previous command? Yes, it is press the up arrow, very much like if you've ever used a Linux terminal or PuTTY or stuff like that. Let's see who the winner is.
Sophia in third, Dominic in second, and first place is
Hey, Margot has maintained her lead. Very nice.
I think I have your guys' email from the check-in, so make sure you did that already. And now we can get started on our project.
All right, let me stop my screen share.
Okay, I will start sharing. think it's this one. All right, so our project is going to be plotting electricity usage across different sectors. So we have 3 sectors: residential, commercial, and industrial. And this is what it should look, your plot should look like in the end. And the usage data represents the US electricity consumption for different years in the month of July. So as you can see, the x-axis, this is different years. And the usage data is in 10 to the 9 kilowatts per day. So what you need to do is download the zip file and go into that directory on MATLAB using your change or current folder workspace. So I'm going to share. I'm going to share my desktop actually and show you how to do this. Sorry about that. All right, so we're gonna download this. Still loading. And then I think, and then you should have this. So your current folder, you can change it by pressing this little browse for folder and then just check where you downloaded it. Oh gosh, I have the rainbow cursor of death. Okay, so you can just change into whatever directory that contains these 3 files. I'll show you over here. It should be electricity.mat, matlabproject.mlx, and then here's the answers, but don't click on that yet because we're gonna do it together right now. And then once you have this screen loaded, can you type in something in the chat? Like just like got it or like yes. Thanks, Andrew. I love the enthusiasm. Oh, so you click on this icon right here. It's like a green arrow that points downwards. Thanks, Bonnie. How do you say that? Travis, do you know how to say TSK?
See, I would say tisk, but
Oh.
so I've
I
heard it
got it
pronounced.
so wrong. I'm sorry, I'm a boomer.
I'm pretty sure that's a boomer word, so you're fine.
Oh wait, never mind.
You're a zoomer.
I'm damn. Kyan really out here. Anyone else not have the screen loaded? Please type into the chat. Oh, sorry. You don't need all of these numbers on the right. Let me. Yeah, so this is, I already ran the output before, but let me just clear it. I made the mistake. So hopefully if I run this, all will go away. Okay, sorry, I just cleared that output. Anyone not have this? Or I'm gonna go ahead. All right, so you want to load this electricity.mat data into MATLAB. So you want to use this load and then space followed by the file name that you want to load. So you can just do load and then electricity.mat. It should probably like autocomplete for you. And then you would press enter, and then you want to see, oh gosh, and then you want to run this section, and now you'll see on your workspace you get this variable right here called usage. And then if you double click on this, you can actually look at all of these values right here on kind of like a row by column or table. And then going back to this, our first task, we see that there is an NaN value, and what this represents is not a number. Sometimes you might have missing data and you need to replace this with a numerical value. So our first task is going to replace one of the NaN values with the value 2.74. So now going back to, what does it say when you type in load, Ava? I think you might be in the wrong or in a different folder.
Yeah, make sure
Oh,
you check on the left that everything is listed. Everything in the current folder is listed there.
Yeah.
everything, yeah. I think it is. It says ds_score and then electricity.net and then MATLAB project.mlx.
What does it say when you type in like load electricity.mat?
It says error using load unable to read file. Electricity.net. No such file or directory.
Does anyone else have this problem?
Oh, double click the electricity.net. Okay, I'll try that.
You could you could right click and then select load.
Oh, okay. All right, I'll try that.
Thank you, Andrew and Kyan. Okay, so after we've imported it, we have this usage variable right here. We see that on row 2, column 3, we have an NaN value and we want to replace it with the number 2.74. Can someone type in the chat like what I would need to write to replace that value? So row 2, column 3. Perfect. All right, so we're going to access second row, column 3, and then set it equal to 2.74. And then once we run this section, we're going to look back at our usage variable. And as we can see, it's now changed from NaN to 2.74. Okay, so now our second task, the residential data is stored in our first column. So we want to create a variable res that contains the first column of usage. Whoops, sorry, not the answers. Okay, so this is all residential. And now we want to extract the entire first column of all the rows. Can anyone tell me how I would store that into the variable res?
You would do usage colon comma or yeah colon comma 1.
Mm-hmm. All right, so let's set that. Comma 1. And let's see. Oh God. Sorry, the screen share option came up. Okay, now we're gonna run this section and let's see. Now we got the first column and then let's just double check that there it is. Same thing we're gonna do with the commercial and industrial data. It's in the second and third columns of usage. Can anyone just type in really quick in the chat what I would write? Perfect, Krisha. So column is going to be equal to usage. I'm extracting all the rows and then taking the second column because that's what it told me in the task. Same thing for the industrial data. We're going to take all the rows and then we're going to take the third column. If this doesn't make sense, like feel free to just ask in the chat and I'd be happy to go over it again. So I'm going to run this and then we should see these two variables. These two variables be made. Then our task 4. So our usage data was collected annually between the years 1991 to 2013. And we want to create a years variable that will help us plot the data over a meaningful range, which is this. So now we want to create a vector named years, a row vector named years that represents the years starting at 1991 and ending with 2013. Can anyone type in the chat like what function or syntax they would use? All right, perfect, Dominic. So by default, the step size is already 1. So you can still just do 1991 and then 2013. And that should give you the years. Sorry, my dog just walked in. Now let's run this section. And now we see all of these years are created, oops, from 1991 to 2013, kind of consecutively. And then now here's the fun part. We want to create a plot with all the 3 columns. Years is going to be our x-axis data, and we would use this order and plot the specifications. So our res data, we want a blue dashed line. For commercial, we want a black dotted line. And for industrial, we want a magenta dash dot line. And so if you recall, we might want to use plot and another function that I won't say in order to plot all 3 of this data onto the same graph. So if anyone can give me like the first line I would write to plot the res data. All right, so Margot gave me plot years res and then b dash dash. And now I'm gonna just run it. Oh my God, I'm sorry, I didn't show you guys the output, but after each task, you can see the output of how it looks like. And we can see that now we have our residential data plotted. And now what would be the next command if I wanted to plot the commercial data on top of the same graph? Exactly, Calvin. Hold on. And then what should be my next command?
Real quick, if I can interject, there's a really good question in the chat. And the reason why doing the linspace command won't work is that you're basically selecting there to be only one number that's written down afterwards. Because remember, linspace is like if you have the start of 1 and then ending of 10, and then you want to evenly space it by, like, you want to have 20 numbers in it, then you'll put 20 in the middle and it'll evenly space it out for you. But yeah, so hopefully that makes sense.
Thank you.
There's one additional command you need to insert. Preston, do you think you can resend? Okay, yes, cut it. Okay, now we're gonna plot years. Now let's go see our commercial data. K and then dotted line. Then we want to hold on, and then finally plot our last one, which is our industrial data. And it's going to be magenta with a dash and a dot. So now let's see how this looks. And we should be able to see a really nice looking plot with all three. I hope you can see with all three of the industries. We're almost the end. Now we just need to add the title, July electricity usage, and creating a legend with the values res, com, and ind. Oh, Preston, okay, sorry. You only need to, I think, put hold on once. It's kind of like a Boolean or property. But this is just like for like sanity that you're plotting it on the same graph. And if you wanted to turn off that feature, you just put hold on. So yes, Preston, you are correct. Okay, can anyone tell me what I should write for task 6? All right, nice. And then what about legend? Exactly. Oops, sorry. And let's see what this output would be. Still running a little bit. Okay, so now we have our title and our legend right here. And then finally, we want our X label and Y label. Can anyone also type these commands in the chat? All right, perfect. Krisha. Okay. You guys have made my job significantly easier. Thank you so much. When would be a good time to use hold off? Say you have like a project that involves multiple graphs, but you don't want to plot on the same exact graph, if that makes sense. Or does it make sense to like plot, like if you had like water and electricity, you don't want to plot them both like on the same graph. You might want to plot them on different ones, and then you would have to specify hold off to create another graph. But yes, this is the end of the projects. And all right, here's just a quick summary.
Real quick, in answer to just a couple last questions. Yes, you do technically only have to say hold on once. It'll carry over. It's just like a switch you flip and then you flip it back off with hold off. And Ava, I believe in MATLAB, it really doesn't matter. You can represent strings either way. I know in C, it's a lot different because single quotes will represent characters and double quotes represent strings, but in MATLAB, either way is fine.
Mm-hmm. Okay, so that was just a summary of commands. Here's some extra resources if you want to look at like other ways you can explore MATLAB. And now our application for the SMD soldering workshop is live. Here's like your final product of what you would like to make. And make sure you apply early. We're going to post again on our Facebook group about like the due date or the deadline and more information on that. And then I'm just gonna give a very quick presentation about like DigiKey because I think it's a really good resource for students. I'm also an ambassador. So if you have like any questions on like if you want to also become an ambassador, like get free swag and also like share information about DigiKey to other students, like reach out to me. Feel free to reach out to me. So there's a lot of information, but I promise it's not actually, not everything is like important on here. So our projects for IEEE actually uses like DigiKey, which is a vendor for electronic components. All of our projects use it. And if you want like to make your own personal project, I highly recommend using DigiKey as a vendor to get all of your components. They also have a lot of resources and tools for students. As you can see, like over here, they have tutorials on how you can make different projects that other students have made. There's also conversion calculators that DigiKey has. Like they have a really useful one where it's like a resistor color code to like the resistor value that I use a lot because I don't want to remember the colors. They also have a website, maker.io, where they have a bunch of other projects that students have made, and where you can upload your own project so other people can see it. DigiKey also has a partnership with All About Circuits for the Ambassador program. So, oops. This is All About Circuits. It's also a really, really good way for you to learn about like other electrical engineering topics on your own. It's basically the world's largest and most active independent online community for electrical engineers. You have like Stack Overflow for, you know, like CS. This is like the Stack Overflow for like E majors. They have a lot of free resources, tools, guides, textbooks, and tutorials on their website. So anything you want to learn about, like anything E related, you'll probably find on here. And that is pretty much the end of our workshop. Thank you so much, everyone, for staying so long. I hope you guys enjoyed it.
We're very happy to see all of you again. And if you're new, happy to see you as well. We also look forward to seeing you at our Verilog workshop in 2 weeks from today. I think that's going to be a lot of fun. It's a little trickier than perhaps MATLAB was, but we'll guide you through it. And we stuck a bunch of really, really bad memes in there. So that's something to look forward to as well. So we look forward to seeing you guys then.
Yes. Thank you so much, everyone. All
Thank
right.
you.
Thank you.
You.
Thank you. Coming. Oh, hi, Kayan. No problem.
All right.
You did it, Travis.
Did it.
Dab.
Workshop number 1 out of the way. That was good. Yeah, we got, I think, 32 people there at High Point. So.
I did see that. We went through like 60 slides. So I had to add so many. It was in order to get the free swag for students. All right.
Yeah.
God, we have to prepare for our meeting.
All right, sounds good. Real quick. So we had Cameron was our first guy who won the Amazon gift card. Do you have his info? Or?
Yeah, Cameron and Mark. It's okay. I can just message him. Under I think.
All right, perfect.
All good.
Yeah,
Caleb
I guess I will.
stayed the entire time. Oh, sorry. Go ahead.
Say what?
Caleb stayed the entire time.
Yes, I saw that.
I wonder if he was like actually listening to us, you know?
Listening to our every word, making sure we didn't mess up.
I messed up.
All right, so then I guess I will see you in 37 minutes at the officer meeting.
Are you gonna go eat?
I actually managed to cram in a meal about 10 minutes before joining up to this meeting.
All right. I'll see you then.
All right, see you later. Have a good dinner.
Bye-bye.